So today it's advertised PDE toolbox. And all it is a finite element CAN program. You saw in the last lectures last week sort of the amount of work it takes to put everything together. Interestingly enough, just went to a talk from a faculty member in electrical engineering who got tenured here. They went off and started a company. And what does he do? He does finite elements on sort of optoelectronic devices, calculates electric fields. This is huge, huge business. There's 4 major players in this arena that do billions of dollars of work, okay, or sales on this stuff. So you think about it, billions of dollars. Wouldn't it be easy just to hire a team to, you know, if you break that up in equally spaced parts, $250 million each? Couldn't you as a company just hire a team for $10 million and just do their thing? You have to understand the power of what the code does, and if you can get this right, and the technical level you need to do it is high. This is why these guys make billions of dollars, and this is why you might be tempted, especially since the UW has, in fact, many licenses for using the software, just to use these software pieces, okay? So I'm going to just show you one, which is probably not a very good one, but it's going to illustrate to you, sort of in some sense, the ease of use of what you can do with finite element sort of package. Okay? So we'll come over to MATLAB and we'll start programming up. And if we could get to dim the lights and I guess project the, you guys seeing the screen on the TV back there? Do you see me? What do you see? Okay. How about if we do for the projection on the TVs, just directly the monitor?
Could you hit project local?
Project local? Like that. Oh, okay, there we go. There we go. Good? You guys see it? Great. All right, so here it is. MATLAB again. And may I just point out, because this is on my mind, my cup of coffee this morning was just not quite as good as normal. I don't know what happened. If I just didn't quite steam it right, you know, get to a good wrist pour. So I'm going to have to come back to that later today. Usually, you know, I get a good one going, and I'm like, okay, I'm ready. And then today I was like, dang, I'm off for a little bit. So we'll see how it has impact on lecture. Okay. So, by the way, you see that I was playing with this morning, and maybe that's what ruined my cup of coffee. PDE tool. That's the PDE toolbox. All you got to do is say that. Actually, type it. And here it is. Now the problem is going to be trying to see if we can fit this all in. Okay, well, good, we can. Kind of. Here it is. There is the PDE toolbox. Now, it will be a little bit hard for those of you who slept in or watching at home to maybe see what all those buttons say, because but they're there, and we'll try to go through them. And what it is a collection of graphics. Let me walk you through. There's right on this row here, there's a collection of graphics. And by the way, everything that's in this row is also set in English up here. They're really identical. Okay? And so you can either use it as sort of in sort of visual mode, just in terms of picking things out here, or just go through and pull things down here. So first of all, this is your canvas. You are the artist. So let's make some art. All right. So let's talk about these first 5 boxes. There is a rectangle. There's a rectangle with a plus in it. There is an ellipse with a plus in it, and a polynomial. It could look like a duck beak, but ducks. What can you say about ducks? All right. What's that? Turbulence flows around ducks. There's something. All right. So first, let's start off with, you know, a rectangle. And look, it gives me a little plus sign when I push the button. And it's because I can draw a rectangle. Woo! R1, which means rectangle 1. By the way, what happens if I do the plus? That means wherever I start from, I build my triangle. So wherever I put that plus, that's where the triangle starts. It goes outwards. Before, wherever I put it, that was the one corner to another corner. So it's a corner start or a center start on your rectangle. There's 2 rectangles. There's my domain so far. Oh, by the way, I can do this with ellipse too. can make an ellipse. Look at that. Boom. See all these kind of cool things I can do? And I can do a centered ellipse, and we'll start the center of the ellipse. How about right there? It kind of looks like a circle, too, or whatever you want to do. I don't know. What do you guys like? That? Let's do that. All right. Check it out. Or I can do polynomial. Boom. Check out that domain. I want you to solve a PDE on that. Okay? All right, so you're screwed. Except you have this toolbox. And in fact, this is basically what you can do with these 5 buttons, is draw these domains. So by the way, drawing these domains, there's a draw button. Draw mode. Rectangle, square. Rectangle, centered. Ellipse, ellipse centered. Polygon, rotate. Ooh, let's go rotate some. Oh, I moved it. Shouldn't I be able to rotate it? Yeah, come on, rotate. If I was smarter. All right, so let's pretend we rotated. Great, awesome. Awesome rotation there. Nice work. Yeah, okay, so I wonder if it's a... It should be easy. You know, it might be, too, that we have something off the edge here because it's fitting to the screen. I'm wondering if I have something over there because it tells me the location. Okay, but it's not allowing me to rotate right now. Okay, but anyway, here's my domain. And by the way, my formula, set formula right here, you can barely read it because of this way I squished it on the screen and trying to fit it on projector mode of 800 by 600 pixels or whatever. R1, my domain. This is my domain. Is R1 plus R2 plus E1 plus E2 plus P1. That's what comprises my domain. All right, good? So, like I said, you can do that in draw mode. Here's what's kind of interesting about this. You can also do export geometry description, set formulas, labels, all that. So whatever you build in here, you can take out of here. Not just the solution, but the boundary, the mesh, individual pieces that you might want to use later. So for instance, suppose you first wanted to build a complicated domain and then put a mesh on it, and then you have decided, I'll build the AX equal B stuff on my own because I have a set of equations and they're fancy and I want to do something with it. Okay, so you could do that. And you could just have a mesh for you, and you can just have it give you the domain, and then you can export it all and then work with that directly. Okay?
Export to a MATLAB?
It exports to, yeah, that's right. I actually think you can even do more general formats than that. Okay? Or you export it to a MATLAB format, and then within MATLAB you can export it to ASCII and then read it by anybody. Okay? I actually don't know. You know, most software companies, right, they'll, like if you're ANSYS, I haven't never used, has anybody used ANSYS? ANSYS is a finite element. I imagine you save ANSYS files that only ANSYS can read, right? They do this partly because they want you to only use their product and get used to using the product. And once you get hooked, you don't change often, right? So this is part of the philosophy of software. MATLAB is the same, right? Which is, we'll get you hooked in on it. It's like candy. We'll give it to you for free for a while, and then all of a sudden you're like, you don't know how to function without it. It's my life. Do I shake when I talk like that? All right. So all right, there we go. This is our domain. We're going to solve something on it. Now, basically, the solution technique here involves moving from the left box to the right. That's it. So you start on the left, and the first 5 are drawing some domains. The next one, you can't quite see. It's a d omega. And what it is, it corresponds to the second box over here. It's boundary. So if I were to just push that button, boom, there's my boundaries. Okay, so what it did is that I got overlapping regions, but really what I have is this region in red. And by the red means something. So I can actually go here and let's say, let me go to this boundary line right here. See that one right there? Double click it. Oh, right here. Okay, and now it pops this box over here. I pull out from the corner. Boundary condition. Oh, look at that. For that line, I can specify a boundary condition.